Alright, last time I had some suspicions that that's not working. Alrighty, looks like it is now. So did anybody need Monday's recordings? I forgot to go back and look. Make sure they had audio. Oh, hope they're there. Hope the audio is there. So we've talked about 3 different kinds of structures. Sequential, loops, and selection decision. You can stack them. You can nest them inside each other. In pseudocode, we use an end statement to mark the end of a structure, right? Like end if. Or end while will mark the end of a loop. Don't see that in the pseudocode, but it's there, back where they join together, right? We would put a circle there just to make it easy to draw. That would be the end if. And we don't even really see a place to stick an end while at all. But we can see it in the code, right? The end if is where the if statement structure stops, and the end while would be after you're done with the while loop. And again, notice the difference. End ifs split and then rejoin at the bottom. Excuse me, ifs split and rejoin at the bottom, while loops come back to the diamond. And the way I showed y'all to draw the while loop, and it's totally okay if you don't do it that way, is to come back and hit one of the diagonal walls of the diamond. So any task or step in a structure could be replaced by another structure. So if step B suddenly became more complicated, maybe step B suddenly has an if statement involved in it, right? So you could delete that, and you could, add some if statements as long as they got back and joined together at the end. Or maybe step A got replaced with something that had a loop, right? So any block in here can be replaced by one of these larger structures, right? Step D could be a series of sequential steps. It might become 10 steps rather than 1. Step E might be another branch, where that branches off and comes back together, just like this one. So nesting structures is placing one structure inside another. Well, let's talk about that. I'm going to go ahead and load up idle. It's always more fun to have idle going. I believe this is H. All right, here's an example of nesting a structure. Say we ask for their age. I'm just going to hard code the age to 30. If age is greater than 17, colon, print parentheses, quote, you are an adult, end quote, in parentheses. And now we're going to stick another if right inside there. If age is greater than 64, colon, we're going to print, wow, you're really old. No, I'm kidding. You are a senior citizen, supposedly. And then back tab to put an end if, and back tab to put another if, end if. So we have this if statement, this if structure, nested within, encapsulated inside that one. And we could keep doing that, right? We could keep indenting and adding more if statements if we wanted to. So under that print statement, I'm going to add one more. If age is greater than 130, colon, print, I think you are exaggerating. All right, so now we've nested an if statement that's inside an if. We've nested an if block, which is inside an if block, which is inside an if block. And not right now, since age is equal to 30, it's only going to print that. It's going to dip down in here, print that. But since our age is not greater than 64, it's going to skip the rest of that. Like this. Drawing on the board, people watching the video don't get shit. All right, so we added a statement. If age greater than 17. If that's true, we tab over. We printed something. We print that they're an adult. And then we add another if statement. If age is greater than 64. If that's true, we tab over again. We print something else. We print that they're a senior. And we add one more. Lastly, it was 130, I think, something like that. If age is greater than 130, then we print you're a liar. All right, and then everything hooked back up. Like that. That's our structure. So we can see that the only time we ever say that they're a liar is if their age was greater than 17, and if it was greater than 64, and if it was greater than 130. And at any point, if any of these are false, it's not going to get all the way over here. And that's fine, it's just nested, right? Your age, in order to come over here and check to see if you're 65 or older, had to be 18 or older. I'm going to make sure this works. I'm going to say that I'm 230 years old and run it because I want to see all three messages. And also just to make sure I don't have any syntax errors. All right. Now if I lower it to 30, it should only print you're an adult because it's not greater than 64, so it won't go into that branch. All right, now if we started adding else's and stuff like that, then the logic could get considerably more complex to look at. I mean, it's not harder for the computer to figure out, but, you know, if we added an else here and an else here and an else here, it'd just be a little bit harder to read. I think I'll leave that for right now until we get to an example. So the block is a group of statements that executes as a single unit. This stuff is a block inside this if statement. This stuff is all a block inside, well, from here to here is a block inside this if statement. This if statement's only got an itty-bitty little block of one line of code.
Would you really need three of those statements?
Right. We have an if and an if, end if. We have an if and an end if, and an if and an end if.
And just do one for all of them?
No, that would be like here, deciding to erase some of these little joining circles together. Right. Pretty much every if's going to have an end if in the comments. Good question. It looks kind of silly, but it didn't have to be that way. There could have been some more stuff here, right? Like maybe we put a, you know, something else here. I have no idea what I would stick here. Print, you know, age ain't nothing but a number. There. So this end if ties together with that. And then, you know, we do something else. And then who knows what I'm going to put here. Print here. I miss being a kid. But anyways, this end if tied together with that marks the end of that block. Does that make sense? Okay. And if our age is less than, not greater than 17, we're not going to say a single thing. because this rules it out. We could put an else down here and, you know, have it actually do something else. It didn't, so I'm going to come down here, and in front of my end if here, I think I will put an else. Else colon print, shouldn't you be in school, Sonny? There. Now it'll print something, no matter what. And I'm not going to get up there and draw that logic. Now we've got a whole bunch of ifs and elses and stuff like that. Wouldn't be hard, it's just not going to take the time to do it. At least not right now. So here's a block. This block is indented inside the if. Do J, K, and L if this is true. Now here we've decided that step K is a little bit more complicated. Step K has a loop involved. So this while loop is nested inside this if statement. So like, what is our name? Our name is, name equals, quote, Bob. And then if name equals Bob, which of course it is, I'm just saving us from having to type in input every time we run this. Then we could have some kind of loop. X equals 10. While X is greater than 0, colon, print parentheses X, X equals X minus 1. So, if our name is Bob, for some reason it's going to print out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And since we counted down, we may as well put, after the end while there, print liftoff. Print parentheses, we have liftoff. And then an end if to tie things up there. So this end while hooks up with that. This end if hooks up with that.
What was the double equal sign mean again?
I am so sorry, pardon me?
What does the double equal sign mean again?
Comparison. Double equal means are you equal to? That double equal means are you equal to? It's a question, whereas this is a statement. Single equal sets the value, double equal compares it. That's worth adding a comment. A single equal sets a value, a double equal compares it. Alright, so it printed 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff, but it would not have done that if our name was not Bob, because this while loop is nested inside this if. Just like our PowerPoint showed. I'm going to flip over to it and then I'll bring the code right back. Right? So this could have been, this condition could have been if name equals Bob. And then step J was setting X to 10. And then if X is greater than 0, we print out something, we add 1 to X, and then we keep looping until it's done. And let's confirm that that's the case. If I change my name to Sam, since my name is no longer Bob, I'm not going to see the liftoff message. And I'm going to change it back. Change Sam back to Bob. Now we'll see my liftoff message. There we go. So this is a larger flowchart showing if name is equal to Bob, then do something, and then have a while loop. But inside the while loop, there's another if statement. I'm not going to go and model that in code, but you get the idea. I hope. I could come in here and I could put an if statement right here. Like, what if we really like the number 5? We're going to print a special message if it's 5. So if x equals 5, colon, parentheses, quote, the word 5, end quote, and then back tab, and add an else, and then tab this one over. So I just changed a couple of things here. You don't add these things, right? These are just to bring your eye to the lines that changed. So you'll have to make sure that you indented it properly, because I just pushed this line over an extra level in order to get it underneath the else, to get it tabbed over under the else, get it indented. Now when I run it, it's going to print out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, except the number 5 is going to be replaced by the word. As such.
At the very beginning, what is your age?
I set age equal to 12. It can be anything just to test it out, right? If I set it equal to 99, what is it going to print? It's going to print you're an adult. And since we're older than 64, it's going to print you're a senior citizen, supposedly. But 99 is not greater than 130, so it's going to skip that. Then it is going to print age ain't nothing but a number. And then it is going to print I miss being a kid. But it's not going to print shouldn't you be in school, Sonny, because that was part of the else from the original if statement. And it's only going to print that if we're like 17 or 16 or younger.
Alright, so see how if you were to skip out that second indent on if you're under 130,
Yeah.
therefore it's not going to print out the age. Will it print out we have lived on 10 times? See how the code is still manufactured?
Well, these end ifs are just comments. The code would work just as well without them.
No, that's not what I'm
Yeah, so down here, wait, let me undo that change. Okay, so what are we suggesting here?
Take off anything, number.
Oh yeah, it's still going to do all this stuff, right? Because this stuff is completely self-contained in this logic here, so it has nothing to do with what's going on here. So it's still going to do the counting. Does that kind of make sense?
Yeah, okay.
Yeah, yeah. So like this is making the meal, and this is doing the dessert. They're two completely different steps because they don't share any variables or anything. Good question. So structured programs have the following characteristics. Python forces us to write structured programs, but the rules are they can only be combinations of the 3 basic structures: loops, sequentials, and selections. Each structure has a single entry point and a single exit point. Let's look at the flowchart first and see what we mean by that, right? Here we have a single entry point into this structure, and then finally there's a single exit point. Once we get down in here, we have a single entry point to this loop. And it may loop and loop over and over, but there's only one exit point. When we're inside the loop, there's a single entry point into this if statement and a single exit point. And there's no dead ends. There's no place where one of these blocks suddenly splits off into 2, right? Step Q can't go like, okay, I'm going to go over here and I'm going to go over here. The only thing that can split off into 2 ways are the decision blocks, and eventually they have to hook back up.
How would you know when they hook back up?
You decide based on like the end if comments or something like that. If this is a loop, keep doing something until I'm done, well, it's going to hook back up at the diamond because we have to figure out, we have to keep repeating until we're done. This is the are you done step right there. And this is the decision, like are you greater than 17, print adult, else print kid. Well, when we're done figuring that out at that end diff, then they hook back together. So here's our example. Are we planting flowers this year? Yes or no? Well, no, we're not going to do anything. Okay, fine. Are we planting flowers this year? Yes. So we need to buy some flowers in some pots. Then, is the frost still possible? Yes or no? Well, if frost isn't possible, then we can just skip and go down here. Put the flowers in the pounds, in the ground. But this is structured as a loop. So I would have not put the word is, I would have put the word while, because the word while would have been up here. But anyways, is frost still possible? It sure is. But is it over 50 degrees today? Yeah. Okay, well, we're going to bring the flowers out for the day. But if it was not over 50, then we're going to keep the potted flowers inside for the day. And we're going to keep repeating this until frost is no longer possible. So we keep looping. Here's the single entry point for the if, and the end entry point for the if. Here's the single exit point for the while loop. There's no way to get out of this structure until you go there. Here's the single exit point for this if statement, based on whether we are planting flowers or not. So, everything is built from the three structures. Everything has a single entry point and a single exit point. The structures can be stacked. They can be connected to each other only at their entry or exit points, meaning that I'm not going to have a line that suddenly goes from here down into here, right? That would be cheating. If I drew an arrow going from there to there, this arrow has to go to here because that's the entry to that logical structure. And this arrow has to go to here because it's the entry to that logical structure. And if we compare it to the code may actually be easier to understand than a flowchart. Some people think certain ways, some people think in other ways. But are we planting flowers this year? Yeah, we sure are. If we weren't, we wouldn't be doing a dang thing. Buy the flowers while frost is still possible. Is it over 50 degrees today? Yeah, sure is. Take the flowers out. Else, bring the flowers in. End if, end while. And it keeps looping as long as the while the frost is possible. When it's finally done, we plant the flowers in the ground. All right, using a priming input to structure a program. That sounds complicated, but it's not. It's basically, how does the loop start? If I'm going to read every book in my library, I have to pick up a book, right? I'm not going to, every journey starts with a single step. No, something like that. You got to do something first in order to get the whole thing going. And the way that they suggest structuring it is with what's known as a priming read. And that's where you get some data before your while loop begins. So something like this. We're going to ask the user to enter a test score or -1 to quit. So print, parentheses, quote, enter a score or Q to quit. Change my mind, not -1. And then we need to get the input. Score equals input, parentheses in parentheses. Or if you like putting those arrows to tell them where to type, why not? And then we can do our while loop. While score exclamation mark equal, that means not equal, exclamation point equal, no space between them. While it's not equal to quote, capital Q, end quote, then we could do something, right? We could convert it to a number. We could add it to a total, right? We could check to see if it's greater than a 90 and tell them they made an A or something like that. So print parentheses, quote, we're just going to fake it. Score saved, end quote, end period. Just because I'm not going to really make it do anything fancy. So I'm just faking it, making it print a message, and now we need to ask them again. What would happen if I didn't ask them again? I'm going to run the program without finishing it, just to show you what happens. Well, for one thing, I broke my code and forgot I deleted a value up here. There's the age equals. Try that again. Alright, so enter a score or Q to quit. Okay, I earned a 90. And it goes into an infinite loop printing score saved forever. Nothing will stop it until I turn the computer off or click that X. Why? Because nothing ever changed the value of score. So it just keeps repeating. So we need to get a new score. So now we're going to just repeat these two steps. It could be just as easy as copying and pasting them. But I'm going to go ahead and add a whole message. Print parentheses, quote, enter another score or Q to quit, end quote, in parentheses. And now I need another input statement. Score equals input parentheses in parentheses, like that. So here's our first input, and here's our second input. I'm going to flip over in a minute to Flowchart and draw that one out. Wouldn't be a bad idea if you drew it with me.
Does the score have to equal the input, or could it be input equals score?
Very good question. If we did it like this, this is a syntax error because it goes from right to left. And so we couldn't take something and then copy it into an input statement. Instead, you have to get the input statement and copy it into the score. Yeah, excellent question. Unlike math, right, where you could say x equals 3 or 3 equals x, and they mean kind of the same thing. But no, the variable has to go on the left-hand side, and the expression that creates the value to store in the variable goes on the right. Yeah. So I'm going to go to Flowchart, and I'm going to draw that little snippet of code. May simplify it a little bit. So I'm just going to copy this code and paste it into my Flowchart. I don't care if you do or not, but I need it on the screen or else I'll forget it. Alright, so I'm going to drag a block out there, paste my code, set it to be oriented against the left margin, try to stretch it out a little bit, maybe make the font larger, and then I'll be good to actually draw it. Okay, so that's a snippet of code. This first input, notice that we did have some code that's repeated. And I don't particularly like repeated code, and there's a way that you could structure this loop in such a way that it didn't have to. You'd have to use something called a break statement. Not talking about that. So we ask them the question, we let them type it in, and then as long as they never type in a Q, we do something with that data, and then we ask them again, and we let them type it in again. So we know what shape a print statement is. That's a tilted. So print or output, I'm just going to use print since it's there in our code. Print, enter, score, or Q to quit. And I can use Shift, Enter to try to tidy up my line breaks. Alright, sneaking back over here, I know that it was input score. Score equals input. So I could put that exactly, score is equal to input. Or I could make it look, you know, more like pseudocode and just say input score. Either would be okay. I think I'll just say input score. That didn't work. Okay. You don't have to take time to try to compress it all. Alrighty. The next statement after our input score was a while, which is a diamond just like an if. But the difference between a while and an if is that the if joins back up together at the bottom, whereas a while has a loop going back up. So, while score exclamation mark equal, not equal, quote Q in quote. I'm going to use Shift Enter right here to try to space it out. We're going to do what it said, which is just a print statement. Nothing real complicated here. So print score saved. And then we repeated these two steps. It's tempting almost just to copy and paste them. We added another print statement and another input. So print, quote, enter another score, or Q to quit, end quote. And then another input score. And I wouldn't count you off if you made this look more like the source code, because we're coding direct. I mean, we're drawing a flowchart based on Python rather than pseudocode. So it'd actually be okay to make the flowchart have some Python in it, where it said score equals input, parentheses and parentheses. But that's not really strictly proper flowcharting, which is supposed to be a little bit vaguer, so that if you gave this same flowchart to somebody writing in Java, they'd be able to do it. Now it needs to loop back up. We are at the end of our code block. If we go and look at our code block, we've hit the, whoopsie, that was dumb. What should this end if actually be? Are there any if statements in this block? Yeah, it should be, you're right, there needs to be a stop as well. But it should be end while, because that's what the structure was. And I didn't put a start up at the top, and I didn't put a stop at the bottom, so let's go ahead and do that. Start up at the top, stop at the bottom. If you actually put the code in your flowchart, if you didn't, then just watch while I do it. Since I didn't put a start up at the top, I'm going to do so now, so I'm going to come back over here and add an oval to the top of mine. But anyways, now I'm at the end of my block here. Right? I've done everything that's inside the while loop. That block is done. So it needs to loop back up. The end while is effectively that line that we're going to draw that hooks back up with the diamond. Now the book would show us hooking it up above it like that. That's cool. That's how you want to do it. That's cool. I like drawing it so that it hooks up with the one of the angles on the side. And sometimes I draw it coming off this other side and coming back there. Either way works. You have lots of choices. If you wanted to make it look like that, that's cool as well. Both are cool. For some reason, I kind of like that one better. So I'm going to get rid of the outer one. Just because it kind of makes a circle, right? Zoom in with some control pluses. I'm going to be picky just because I feel like it. I'm going to try to get my arrow to line up here. You certainly don't have to do that. There we go. Alrighty. And now we're done. There's nothing left. After the end while, which is just that line hooking back up, there's a stop. So, okay. I'm just going to jut off over here and draw an oval and make it a stop. All right. This first thing is the priming input, or the priming read. Why is it called priming? It's the first thing that has to be done. You're going to spray paint your model, you apply primer. More commonly, I use the metaphor, you're priming the pump. Right? You put a bucket under the pump, you want some water, you got to start pumping the pump before you even get any water, before you can start saying if bucket is full, right? So pump, 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 and then while bucket is not full, get more water, get more water, get more water. But if we never primed it and we never pumped it to begin with, it wouldn't go. So I think I'll add an annotation here saying that this is the priming read. For my annotation, I'm going to use this little note indicator, curly brace. Alrighty. What we're going to do next. If everybody's got this, then let's go here. So a priming input, or priming read, reads the first input. It's outside the loop that reads the rest of it. Helps keep the program structured. So watch for unstructured loops that do not follow this order. Ask the question, take the action based on the answer, and then ask the question again. Here's their example. Input original number. Not EOF, meaning end of file. Are we at the end of the file? No. Then we calculate the answer and we output the answer. Then we do it again. Are we still at... Now this is an infinite loop because we never input a new number. Just like I showed y'all with the liftoff message or whatever it was. Keeps repeating forever because we never get any new input. It's like reading the first line of a file and then doing some calculations and outputting over and over and over, and we never read the next piece of data. We never let the user type in something, or we never take another reading from the sensor or read the next line of the file. So, although this is correct programming structure, it's a bad program. It's a logic error. Now, this would fix the problem, except our code, our language doesn't even support it. And what do I mean by that? It shows us entering a while loop here, right? But then the entry point back to the while loop, the line doesn't go back to it, right? The bottom of the while loop has to just go back to the diamond or right above it. It can't sneak up here and do some extra steps. So now we're going to do it correctly. There we go. Right? Get the number. Are we not at the end of the file? Yeah, do something with it, and then get the new number. So that's a properly structured while loop that is not an infinite loop and doesn't have this illegal step here that we could not implement in Python. So why do we use structure? Well, because the language makes us. So why do the languages make us do that? Because you can get some languages that do not. Clarity. Unstructured programs are confusing. A spaghetti code is confusing. Professionalism. Other programmers expect you to write well-structured code so that they can modify it. If they're getting paid to fix your code, but you write crap, they're not going to like it. Sorry for the bad word. Efficiency. Most languages support it. Maintenance. Other programmers find it easier to read. And modularity. We can break the code down into modules. What does that mean? Any single step here could instead be a module. What do I mean by that? Well, you remember that line of code here that I had in my program that said score saved? We could do something more impressive with it than that. Let's write a module that gets called by that code. So, the way you define a module in Python is with the def keyword. Like this. def. And I'm going to call my module save score. Save underneath score. And just roll with me on this. I'm going to put a parentheses followed by the word score in parentheses colon. Then I'll go back and I'll explain what's happening there. Let's convert score to a number. So score equals float parentheses score in parentheses. And then we're going to print score saved. So print parentheses quote score saved was end quote comma score in parentheses. And then return. Then I'm going to go down to my while loop and I'm going to delete that line that says score saved, and instead I'm going to call that module. So I'm coming down here. I may just comment it out for now to let you key in on what we're changing, but then I'm going to delete it. So you see that line there. I'm going to call save underscore score parentheses score in parentheses. So that's the line that I just added. Delete that line there, the one above it, the one that I've red lined out, and then add this line. I'm going to run it to make sure I don't have any syntax errors, then I'll bring the code back on the screen. Alright. Enter a score. Alrighty, 90. The score saved was 90. Enter another score, 56. Score saved is 56. Enter a score. I'm tired of this game, so I press Q. So what's going on here? When it hits this statement here, it's calling the module. Why is it calling the module? Well, a module is a module call, a function call is when you have a word followed by the parentheses. What it does is it looks for a defined module that matches that word. Now, if it's a predefined module, a built-in module, which one programming book called a BIF, built-in function, those show up as purple here. So we didn't have to write a print function or an input function. But we had to write that function, so it searches the file for the word save score, followed by the parentheses. Whatever this is, This is a piece of data that gets passed into the function right there. And so this is data that this function can use, this module can use. It turns it into a float, it prints it out, and then it returns. What does return to? It jumps back to where it was. So if we were going to flowchart this, it'd look a little bit different. If you can, I want you to copy your entire flowchart and paste a copy of it. What do I mean by that? Use Control minus to zoom out a little bit. Then select a whole bunch of it. Control C for copy. Control V for paste. And just move it down here. So what did we do in our code? We replaced this print enter score with another line of code, right? That's why that's commented out. We replaced it with a call to a module, save score. Okay, well, a module call is done with a different shape. It's done with one of those math shapes, except it's got bars on it. Where's the one with bars? There it is. It's called a predefined process block. Now, you only use these for function calls, especially functions that you've written. So I'm going to drag one of those guys out, and I'm going to delete this one, just like we commented it out. I'm going to push this over there inside it. The name of the module was save score. Save underscore score parentheses score in parentheses. I'm going to go back and talk a little bit more about what this parentheses score business means. It's not actually the whole point of the lecture, but the idea is to introduce doing a module as part of our program. I consider modules to be the fourth logical structure along with selections and sequentials. I consider them slightly separate from it for the reasons that we will see. We're going to define this module in our flowchart. We had it defined in our source code, but we don't have it defined in our flowchart. Here's what the module looks like. It's got a def, it's got some math, it's got an output statement, and it's got a return. So it's going to be 4 blocks long. Well, modules start with an oval and they end with an oval as well, but the oval they start with is the DEF, and the oval they end with is a return. So let's do that. I'm going to come over here, DEF space save underscore score parentheses score in parentheses. Now the first line the module did was convert score to a number, to a numeric. That's just pure and simple math, so I'm going to put it inside a process block, a regular rectangle. Score equals float parentheses score in parentheses. And then we printed a message out about it. Print save score was, or saved score was, end quote, comma, score. And then the next line was a return. We've done that line, the float, we've done the print statement, and now we do the return. Return.
Would you have the parentheses on them?
I did just because I had been everywhere else. It's okay to put the parentheses when you're doing the flow chart if you want. But if you look everywhere else, I did the same thing. just because in the prior days we hadn't been doing flowcharts with parentheses, so I left them out here now. But it's totally okay to have them in there. If you feel like having parentheses after your print statements because that's how you did it in your Python code, you can do that. Alright, I'm going to zoom back out now. Control minus minus minus. Thank you for pointing that out. Alright, here's what our flowchart looks like now. I'm going to use color for this just to show that this is a module call. It's correct without it, but I kind of like it to make it leap out and grab me. So I'm going to click on that save score thing, come over here, click the paint bucket, and maybe make it a pale tan or something. And I'm going to make this, the oval for the module the same color. There. I just have that there because it makes it real clear that that hooks up to that. Now the book is going to show, at least the first few times they do a module, don't draw this, an arrow going there, like I said, don't draw it because I'm going to delete it, and an arrow coming back. Because that's what it does. That's what a module call does. When it hits save score, it jumps over here, it does these steps, and then it comes back. But that is actually shown logically just by the fact that that's a box with the bars on it. Now the book shows a box with a horizontal bar rather than the two verticals, but the two verticals is what we have in our drawing program, so that's what we're going to use. If I had more than one function, like just pretend I had two different functions, like this, and I wanted to differentiate their calls, I would make a second one have a second color. That's just me. That's my my little personal quirk. And so then if we were going to call that module, then I would color that one pink, right? Just to show. Just to show. That's the only reason I would do that, right? So that when you're looking at the code, it's instantly obvious where this one's going. Run over here, do all that, come back. And then, oh, run over here, go all the way, come back. I'm going to undo those things now. Alright, so that's how you flowchart a function call, a module call. A module that you've written. If we wrote the module in our Python code, then it should show up in the flowchart. Now normally you define your modules up at the top of the file. And if I was going to follow that guideline, I would take this code right here, that DEF save score, cut it and move it to the top of the program right underneath the initial comment block. But that takes it a long way from here, and so when we're looking at our code examples, I'd like for the module to be right where we use it, so I'm going to leave it there. So structured programming is sometimes called go-to-less programming. You remember the example I did on Monday, I think, where I had some statements and they said things like if this, then go to something else, and that made the spaghetti code. Well, so by taking all the go-to statements out of the language, it makes it go-to-less programming. I'll never ask that term on an exam. Recognizing structure. I'm not sure what the point of this slide is, but is this a selection or a loop? This one on the left.
Selection?
That's a selection. Over here we have both a selection and a loop. Which one's the loop, D or E? D is the loop because it goes in here and then comes back to itself. E is another selection because it branches and then joins back at the bottom. Now I guess these are all bad examples maybe? I'm not sure what this slide's showing me. This program is not structured. Why? Because the if statement should join back together in a circle. not join back together after some lines start sneaking over into it and stuff like that. This one's lousy because it just ends in an if. This one's lousy for what reason? Why is that bad?
There's no true statement? Or?
Yeah, there's no true, there's just a false. There's only one way out of it. Lots of blocks only have one way out of it, but not if it's a diamond. If it's a diamond, it's got to have two lines leading away from it. Now this one could be right, it's just kind of unfinished. These should hook back up together in a circle, and then these should hook back up together in a circle. So it's a nested if statement, so there'd be an end if circle right here and another end if circle right there. I like that. We finally had a good one on this page of bad examples, right? So there's our first end if, and there's our second end if. This is nested inside that one. So, summary. Spaghetti code. Statements that do not follow rules of structured logic. They have go-tos. They have lines that are impossible to actually program in our Python, because you can easily draw a flowchart that is impossible to program. You can just make the lines cross and go from this block to that one with reckless abandon, and you couldn't actually program it. The three basic structures, sequence, selection, and loop. You combine them by stacking them or nesting them, or putting them in other modules. Your priming input is a statement that takes the first value prior to starting the structured loop. Now we had a special value here in our code. Right here. We checked to see if it was Q. Q was a special value that stopped the loop. They could type in anything they wanted to, but if they typed in a Q, we stopped programming. we stopped running. Kind of like, enter your bowling score, or 0 to quit. No, that'd be a bad one, because you really can't roll a 0 in bowling. And -1 to quit, right? That kind of thing. This is what's known as a sentinel value. A sentinel value is the value that stops the loop. If we want to get a little bit wordier about it, we would say it's an invalid piece of data that stops the loop, right? Because Q is not a score. But I'm just going to say it's a value that stops the loop. Let's write another loop that actually does something with the score that we get, but we're going to write it a little bit more concisely. In parentheses, quote, sorry for ignoring those scores. Let's do it again. In parentheses, end quote. Print. Enter score or -1 to quit. End quote in parentheses. Score equals input, parentheses, in parentheses. I seem to be inconsistent now about whether I'm going to be putting this thing inside the input statement or not. I guess I'll leave it off. Then we need to convert it to a floating point number. So score equals float, parentheses, score. And now we're going to be adding all these scores up. So we need a variable to hold the sum of all of our scores. So I'm just going to call that total. Total equals 0. And by the way, the spaces don't matter. All right, while score, I can make it greater than -1, not equal, exclamation mark equal, space, -1, colon. Let's add that to our total. total equals total plus score. And now we're going to have to repeat these three statements. And this is really why I don't like the priming read structure. Is because you wind up having code above the while loop, and then you wind up putting that code inside the while loop. We already saw that up here, where we printed something, and then we inputted something, and we did the same thing. Okay, so anyways, the fastest thing to do would just be to copy these three statements and paste them. So I'm going to grab this print. I don't want the total equals 0, but I want the other three print statements. So grab those three, copy them, and paste them. And make sure they're all tabbed inside. Then I'm going to add an end while. I did it again. I keep using, oh, I think I've already fixed it on that one. If you have a while statement, it needs to have end while as the comment at the bottom of it. So anyways, I'm going to do that here as well. End while. And let's print the total. As a matter of fact, we could have been printing the total every time. Just for funsies, let's do that. Let's go above this print statement here inside the while loop and add print parentheses quote total so far is end quote comma total in parentheses. And then after the end while, let's print the total. We're all done. Print parentheses, quote, total of scores equals, end quote, comma, total. Now, if I don't have any syntax errors, let's find out. Then I'll bring the code back. All right. Enter a score or Q to quit. 5, 6, 7. Well, it's not doing anything, so I'm just going to press Q. Sorry for ignoring the scores. Let's do it again. Enter score, 100. Total so far is 100. Enter another score, 200. Total is 300. Enter score, 7. All right. I can keep adding to my total until I finally type in -1 because that is my sentinel value. And then it prints out the total of the scores. So this is using a loop for accumulating, for summing, for getting the total. This total variable has a technical name. It's the accumulator because it accumulates all the values. Whenever you see something written like this, x equals x plus y, total equals total plus score, something like that, you can shorten the way that it's worded. You could write it like this. Total plus equals score. That just means the exact same thing, and it's a shorter way of doing it. So pretty soon I'm going to switch over to doing it this way all the time. So I just want you to recognize it.
I tried the syntax error.
All right, let me come back there. Excellent question. What if we wanted it to support a lowercase q as well as an uppercase q? We could do that one of two ways. One is we could rewrite this while statement to also check for lowercase q's. And that would look kind of stupid. I'll show you what it would look like. And, I mean, I guess it's not that bad. And score not equal to lowercase q. while the Q is not an uppercase Q and the score not equal to a lowercase q. I'm going to delete that though because I think that there's something that we could do that might be a little bit better. If we do score equals score dot upper, parentheses in parentheses, that should take whatever they typed, and if it's a letter, convert it to uppercase. And then it's safe for us to compare against uppercases, even if they type in a lowercase. Or not. Oh, because I didn't add that here as well. To completely fix it, I need to add that. You know what? I guess adding it to the while loop instead was actually better. But since I've already started going off this way, I'm going to add it. Score equals score dot upper. I had to add that after both input statements. I had to add it after this one, and I had to add it after this one. And I guess since I'm sitting here staring at this input statement, I'm going to go ahead and add my little arrow. Now it should work, and now it should let us type in the lowercase letters as well as upper. Except if you don't put it in the right place. All right. Very good questions. I wish the answer was easier than what we just did. It would have been easier if we had not have used a priming read, which required us to have the same code repeated in 2 places. Right? We had those 3 lines of code effectively there and there. The other way we could have done it is with that and word. While score is not equal to uppercase Q, and we could have tacked on and score not equal to lowercase q. That would have fixed it either way. I think I'm going to delete that. Maybe not. Maybe somebody wants to know it. Alrighty, let's take a break. We'll come back. Get back at about 1:20. And we are at the end of the chapter. So since we're done with chapter 3, get the exams on MindTap for chapters 1, 2, and 3 done if you haven't already. It's one of the best ways to study. Okay, so making decisions. This is one of those chapters that we're going to kind of fly through because we've already talking about if statements and things like that. So, but we're going to add on to it, of course. So the selection structure. Good old selection structure. That's our if statement. What it does, technically, is that the thing after the word if, whatever's after the if and before the colon, is something that he has to evaluate to true or false. Is x equal to 0? Is score equal or not equal to q? right? That kind of thing. We could kind of prove that. This is going to be a little bit silly, but if I went up to the very top of my code, and if I did this, if true, colon, print, wow, it's true, you need to do that. Come to think of it, I'm going to be putting all my new notes up at the top of the program so we don't have to be entering those scores and stuff like that. So right above this age is equal to 30, I'm going to go ahead and do input parentheses quote, hit enter to continue. Just so that when I run it, from now on, before it starts doing all that score business, it pauses. And I can just close the window rather than let it go on doing. And if I feel like letting it, you know, I can hit enter and let it go. Okay. So anyways, if true, print wow, it's true. It's always going to print that it's true. Because the expression before the colon, oh, and by the way, Anna asked, how do you know when to indent? And I gave an answer which sounds sarcastic and it's really not. Experience. You know that you need to start indenting if it's part of a logical structure, like on your flowchart. If you hit the if statement and you tab off to the right, well, then you're going to start tabbing off in your code. And you're going to keep tabbing until you hit the end of that structure, which is why we've been putting indiff there, like that. Same for the while. We had a while, and then we had some stuff that jutted off to the right on our flowchart. Well, everything that jutted off to the right was also tabbed, an extra tab over in our code. Now, what if we did this? Again, this is stupid because print while it's false. That's never going to happen. It's never going to print this because this evaluates to false every time. So if we wanted to add some notes about what that's doing, quote, 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 the syntax is if space Boolean expression, colon. And what's Boolean expression? It's an expression that evaluates to true or false. A Boolean expression is one that evaluates to true, except this language likes to capitalize T, true, or capital F false. For example, if age is less or greater than 17, you either are or you aren't, right? If temperature is less than 0, it either is or it isn't. If score not equal to -1, it either is or it isn't, depending on what they type. Those are all Boolean expressions. If we took the word off, it's the Boolean expression. So this is the keyword, and then the age greater than 17, that's the expression. So age greater than 17 is the Boolean expression, and it evaluates, I don't know why I'm having trouble typing that word today, it evaluates to either true or false. Some languages make you put parentheses around the expression. Maybe that makes it easier to read, or maybe not, right? Like that. I'm going to delete those parentheses because it's not part of this language. It works. It's just not necessary. But it kind of highlights, well, that's the Boolean expression. It's going to be either true or false. But now I'm going to take those out. Bless you. So every decision yields a true or a false, a yes or a no, a 1 or a 0. Underneath it all, we know that computers are just all about the numbers, and so 0 is a false and a 1 is a true, but we don't see those inside of, you know, we don't have x-ray eyes that are watching the computers treat trues as 1s and falses as 0s. So this is a dual alternative. This is a rehash. We've done that. A dual alternative is two different things. It's got an else. Dual alternative if is the if else structure. Does one thing or another. Single alternative if has no else. Does one thing or nothing. So dual alternative if age greater than 17, print you're an adult. Else, colon, print you're just a kid. If score less than 60, colon, print you failed, take the quiz again. Right, so that's a single alternative. It doesn't do anything different if the score was greater than 60, but if it's less than 60, it prints a message. Now I'm going to go back and I'm going to add end-if comments. Remember, the comments aren't necessary. They're just there to read. So I went back to this age greater than 17 and added an end-if, and I'm going to do the same thing down here. We put those there in the pseudocode, so why not put them in our code as well? So here they have a fancy word for single alternative because they introduced a fancy word for binary. I mean for dual alternative. If the exam, excuse me, not my exam, but if the test on MindTap asks what a binary selection structure is, it's a dual alternative. Binary meaning two. And if they ask what a unary structure is, it means single. One alternative. Do something or nothing. These are the good terms, dual alternative and single alternative. Those are the ones you'll see in other textbooks. So, if then else, that's a dual alternative. The then part does the thing that's performed when it's true. And the else is what's done when the condition is false. So, if we're greater than 17, that's the then clause, right? If age greater than 17, then print you're an adult. That's the then clause. And then this is the else clause. Print, just a kid. So this is the then clause. And this is the else clause. I should write my material ahead of time and come up with a joke like Santa Claus. Then we would all laugh. All right. So that's the else clause as opposed to the then clause. Now, relational operators. Relational operators are like less than, greater than, less than equal to, greater than or equal to. Here, this actually should be two equals because just like what Anna asked about, you have to have two equal signs when you're doing a comparison. So the relational operators just compare one value to another. Just like we were doing all the way back to grade school when we were checking to see if, circle the one where, 3 is less than 4 or something like that, right? So relational operators, there's 6 of them. Less than, greater than, less than or equal to, greater than or equal to, just flat out equal to, two equals, and then not equal to, not being the exclamation point. At a certain point, I'm going to stop saying exclamation mark equal, and I'm going to say not equal exclusively. So, dot dot means equal to. That means not equal to. And we already know what less than and greater than business is, so we don't really need to talk much about it, except I need to talk about the opposites. Now you might think that the opposite of less than is greater, and that the opposite of greater than is less than. And that's not true. Sounds true. It's almost right. But let me explain why. What if you have this? X less than 3 as opposed to x greater than 3. Are those opposite statements? No, they are not, because what if x is equal to 3? It works for some things, right? Like if x is equal to 1. Is 1 less than 3? Yeah, it is, so that side's true. Is 1 less, don't type this word true, I'm going to keep changing it. Is 1 greater than 3? No, it's false. So that worked, right? Those are opposites. How about if x was 10? Is 10 less than 3? No. Is 10 greater than 3? True. Yeah, so those are opposites, but what if x was exactly equal to 3? Is 3 less than 3? Technically, no. 3 is not less than 3. All right, is 3 greater than 3? No. Okay, so that's where it breaks down, is when it's exactly equal to the value being compared. So, in order to get opposites, the opposite of less than is greater than or equal to. The opposite of less than is greater than or equal to, and the opposite of greater than is less than or equal to. And the opposite of equal is not equal. If you get that wrong, then sometimes when it's on that edge condition, that boundary condition, you'll get the wrong answer, right? They are calling equal the equivalency operator. Okay? Greater than is called the greater than operator. Less than is called the less than operator. Greater than or equal to operator. Operator just means symbol, like the addition operator is the add, the plus sign. And the multiplication operator is the asterisk, the time sign. Less than or equal to, and the not equal to operator. Now this is completely and totally wrong. The book shows this as being the not equal to operator, and I've never seen a textbook, excuse me, I've never seen a computer language actually do that. What have I said several times means not equal? Right. So I guess if MindTap tells you, what makes you pick from a list to find out what the not equal operator is, just remember that, because I think we did that in grade school, right? And I think that's how you said things were not equal to each other, but unfortunately programming languages don't. So we use exclamation mark equal to mean not equal. And any decision can be made with these 3 types of comparisons. Now not equal can kind of make things harder to think of. Like when you take a writing course, you're told not to use double negatives. I'm not going to not go. Okay, does that mean or I have to figure that out? Does that mean I'm going or not? I ain't not hungry. Okay, that's even worse because we throw the word ain't in there. But ain't is, you know, we can figure that out grammatically. Ain't means am not. I ain't not hungry means I am not hungry means, right, throw your hands in the air. Now logically, the computer knows exactly what it's supposed to do if it sees not equal to, but it can be hard for us to think about. So if you can rephrase it without the not in it, you're better off. So, best to restrict the usage to an if without an else. If you're doing something or nothing, yeah, go ahead and use a not equal to. But if I had a choice of saying something like this, if x equals 0 else something, or if I had the choice of saying if x not equal to 0 or else something, I choose the top one. If there's an else involved, you may as well make that the matching case, the then clause the matching case, and then make the else clause the non-matching case, rather than making the then clause the non-matching case and the else clause the matching case. Just easier to think. The program doesn't care. It works as long as you get the logic right. It'll do it flawlessly either way. It's whether your brain understands it as you're writing it or not, and when you come back to read it later. I'm just going to put a little note here. If you type that in, I don't care if you did, but that's kind of the preferred. Preferred to put the not as an implicit part of the else clause. Not to get too fancy with our words. Rather than doing it like this. But if it makes sense to you when you're writing the code, if that looks clear, go ahead and do it. Who cares what the book says? Do what makes the code look clear and comprehensible to you. So, common errors. Yeah, just use the wrong symbol, right? You meant greater than, you do less than. Or you miss the boundary, whoops. You miss the boundary or limit required for a selection. So, and logic. There's and then there's or. And is kind of like this. Do you remember when we had if age is greater than 17 and then we had if age is equal to 30? Right, greater than 30. If age is greater than 17, colon, if age is greater than 30, colon, print something, right? Okay, this is a really stupid example. Let me come up with a better one. All right, how about if money is greater than 0, colon, and then the next line is if hunger greater than 0, colon, then go buy a Snickers. Okay, there we go. For us to buy the Snickers, we have to both have money and be hungry. There's no point in buying it if we're not going to eat it. There's no point in going to the machine if we don't have any money. So this could be rewritten using the and word. Rewrite using and logic. If money greater than 0 and if hunger, except you don't put the word if there. That was my mistake. And hunger greater than 0, colon, 2, 3, 4, print, go buy a Snickers. Now, when I typed the word if there, it sounded good. If money greater than 0 and if hunger is greater than 0. The reason why that would not be correct, don't type this word if because it's not correct. The reason why is because, do you remember when I was showing putting parentheses? This part has to be something that evaluates the true or false. And that if word in there breaks it. So that was not correct. I guess that's one reason why those parentheses that the other languages require might be kind of nice. They do kind of hammer in what you're looking at. But anyways, okay. So both of these true. Both of these sides have to be true, right? Our money has to be greater than 0 and our hunger has to be greater than 0. So for and means both sides must be true for the result to be true. And that's how we think, right? If I'm thirsty and I have some drink left, drink it, right? That's what and means. It means both of them have to be true. And then there's or logic. What if we had something like this? If sick greater than 0, if our amount of sickness is greater than 0, print parentheses, quote, stay home, end quote, in parentheses. And then we had another one, if tired greater than 0, colon, print parentheses, quote, stay home. We get to, we're lucky dogs, we get to stay home whether we are sick or tired. Must be nice. We don't have to be both sick and tired to stay home. One or the other is enough. We could rewrite that using or. Rewrite using or logic. If sick greater than 0 or tired greater than 0, colon, print parentheses, quote, stay home. end quote, end parentheses. Hope that makes sense. And means both sides have to be true, or means only one of them has to be true. So, or means only one side must be true for the result to be true. Now, if they're both true, so much the better, right? But I get to stay home if I'm sick. I get to stay home if I'm tired. I get to stay home if I'm sick and tired. That's what or means, either or. So you can construct something what's known as a truth table for and or. It kind of looks like this. Technically, we have this boiling down to something like this. If X and Y. Or if X or Y. I really don't know if you want to type in what I'm just about to show you. But what we could do is we could have X. We could have, get away from me. We could have Y. And then we could have the result. And this is a result of X and Y. Now I'm going to abbreviate true or false to just T or F. So that's a false and that's a false. That's a false and that's a true. That's a true and that's a false and that's a true and that's a true. We only have 4 choices. If you have 2 variables that can only be either true or false, you only have 4 choices. So for and to be correct, for and to result in a true, what does it take? Both sides to be true. So out of these 4 choices, first, second, third, or fourth, which is the only one that would result in being true?
The last one.
The last one, yes. So the result is true. And the rest of them are not. Right? Now, or, let's construct the or truth table. X or Y, and the result. False, 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 true, true, false, true, true. All right. Only one side has to be true for the result to be true. If they're both true, so much the better. So, if they're both true, so much the better. Here, at least one side is true. Good enough to get us going. Here, the other side's true. Hey, that'll take us there. If they're both false, though, the result is false because neither side was true, right? I was not sick nor I was tired, so I had to go to work. I didn't get to stay home. So the only time an and is true is when they're both true. The only time an or is false is when they're both false. So these are the truth tables. This is the excuse me. Thank you. This is the and truth table. And this is the or truth table. I'm going to show you something. If we replace those T's and F's with trues and falses, with zeros and ones, we may notice something. You see what I did? I just replaced all the T's with zeros, and I'm replacing all the trues with ones. Now I'm going to grab this one as well and do the same thing to it. So that's a 0 and the rest of these are 1 because they were all true. There we go. All right. 0 plus 0 is, no, not plus. That's not going to work here. One of these looks like multiplication and one of these looks like addition. Which of these looks like addition? If I come down here, a 0 plus a 0 equals a 0. A 0 plus a 1 equals a 1. A 1 plus a 0 equals a 1. And a 1 plus a 1 equals a what? Well, Boolean logic can only be one of 2 states, right? True or false. So we're just going to pretend that 1 plus 1 is equal to 1. How about multiplication? 0 times 0 is equal to 0. 0 times 1, well, anything multiplied by 0 is still 0. 1 times 0, still 0. And 1 times 1 equals 1. So, and can be thought of as logical multiplication. And if you go and take a a logic course at a 4-year university, heck, maybe they even offer logic courses here, I don't know. Maybe they do it in discrete math. To represent AND logic, you just use multiplication. And OR can be thought of as logical addition. I didn't finish that word right. Logical multiplication. And so OR is logical addition. I don't know if that'll help you remember the differences between the two or not. But since AND is logical multiplication, the only time you're going to get a non-zero result is when they're both non-zero, when they're both true. And since OR is logical addition, the only time you're going to get a false result, a zero result, is when both inputs were 0. Then there's one more itty-bitty truth table. Not. Not just means the opposite of. I am well. I am not well. Right? True or false? So, if you have not X and then the result, right? Not true is false. And not false is true. A very short truth table. I'm going to replace the word not here and delete them because they're kind of implied by the header. Okay, so if we Google up truth tables, here's a great big one, which I'm not going to focus on. Here's a shorter one where they're using a downward arrow to mean and. I guess if we kept looking, we'd find another one where an up arrow meant or. I'm not digging that one. I'm going to hit escape on that. Here we go. This is looking a little bit better. That's just one of them, and that's the other one. Okay. This one is false only one time when both inputs are false. So is that an and or an or? Don't look up here because it's actually wrong. Nope. Nope, it's correct. Right? A true and a true is a true and a false is a true, a false and a true is a true, and a false and a false is a false. So that's the binary table. That's the binary truth table for or. And if we skip over to my next tab, that's the binary truth table for true. Both inputs have to be true for the result to be true. And so, yeah, they're using an up arrow to mean and a down arrow to mean or. So an and can be replaced by a nested decision or vice versa. Remember my code where I did a nested if up here? If I had money and if I was hungry, buy a Snickers. I use the and to replace the nested ifs. Another word for nested ifs is cascading ifs, because a cascade is like a series of short waterfalls. Now, I hate wasting 10 minutes of time to lecture about this, but I guess since they mention a slide here, and it's on 2 different slides, it's worth talking about. If this code had to be repeated 1,000,000 times right here, where'd my nested ifs go? Here we go. If this code had to be repeated, you know, computers can do things an infinite number of times, you know, millions of times a second. But if it had to be repeated a lot, and we wanted to write it in the most efficient way possible, we would want to put the check that happens least often first. Right. It's very rare I have money. So this is structured correctly, right? Because if I don't have any money, I don't have to check my hunger. It saves me time. If I only have money 1% of the time, then only 1% of the time do I have to check my hunger. Now, I'm Shaggy and Scooby from Scooby-Doo. I'm hungry all the time. So if I replace these two things, if I did them in the opposite order, not hunger. Since Shaggy and Scooby are hungry 99% of the time, we'd have to do the second check 99% of the time. But if it's worded like this, since we only have money 1% of the time, we have to do the second check only 1% of the time. So by structuring your if logic to have the least common condition checked first, if it's an and, the code runs more quickly. Now I'm going to delete that, but I am going to go and tack it on as a rule down here. Way down here at the bottom. For the most efficient and logic, put the expression least likely to occur, comma, first. So, if sick and tired, well, if I'm not sick, I don't need to check to see if I'm tired. If I am sick a lot less than I am tired, then the above way is right. However, if I'm tired a lot less often than I'm sick for me, then I should phrase it the other way for maximum efficiency. Because if this is false, there's no way the expression could be true, right? Because and requires both of them to be true. And so if the first one is false, there's just absolutely no way that the whole expression could evaluate to true. So why even bother checking the second one? Now, or works the other way. If sick or tired. For the most efficient or logic, put the expression most likely to occur first. Why is that? Because or requires only one of them to be true. And so if we're sick, we don't even need to check to see if we're tired. We're already good. And so it doesn't have to do two checks if it can figure out that the first one is true. And so if 90% of the time we're sick and only 10% of the time we're tired, but that doesn't sound very likely. Let's say that we're sick a lot less than we're tired, so we should reverse those. We should put the expression that's most likely to occur first. So, if tired or sick. Because that one's going to be true a lot more often than that one. And so this one, this side doesn't even have to be tested if this is true. So, that eliminates as many instances of the second decision as possible, which speeds up processing time. So the conditional AND operator, we just call it the AND operator, or we just shorten it to say AND. It has two, I don't get where they say or mark questions, in a single comparison. And each Boolean expression must be true for the entire expression to be true. And the truth table shows how that works. Short circuit evaluation means that it only checks as far as it needs to. So if we're checking sick and tired, if the computer checks and sick was true, false, it doesn't need to check tired, so it doesn't. It skips it to make things as fast as possible. That's called short circuit evaluation. I guess that's worth adding as a comment. case it's on one of your mind tap tests. Short circuit evaluation means that the second part of an and or an or can be skipped sometimes based on the first part, which is what led up to these rules about the most efficient OR logic. Put the one most likely to occur first, and for the most efficient AND logic, put the expression least likely to occur first. So thus the above rules. So if I want to go to the movie and I have enough movie, then I will. So that's an AND situation. All right, so avoiding common errors in an AND selection. The second decision must be made entirely within the first decision. I don't even know what that means, but I do know what this means. Both sides of AND have to be a valid expression. What do I mean by that? I cannot do this, although it looks okay. If x greater than 7 and less than 10. It looks valid, except it's not. This part and this part have to be valid expressions, meaning good syntax. If x is less than 7, okay, that's good syntax. And less than 10. Well, what in the world does less than 10 mean? If it was all by itself, we'd have no idea. The computer has no idea, so that's wrong. We can't write it like that. This is wrong. To write it correctly, we'd have to say if x greater than 7 and, nope, and x less than 10. Both things have to be valid Boolean expressions, whether they are a single variable like we were doing here. That variable can be set to either true or false, or whether they're a whole expression like that. That's a common error. Here's another one. People like to write things like this because we learned how to do it in math courses. If 7 less than or equal to x less than or equal to 10. We learned how to write that. Sorry, we can't write it like that. Nope. Not allowed in programming languages that I've ever seen. Instead, you say if x is greater than or equal to 7 and x is less than or equal to 10. That's how you express that. Or, if we hadn't have been using the equals, right, we could just do that. Is x less than 7 and it's less than 10. So if you're going to check to see whether something is within a range, you use AND. To check to see if something is within a range, you use AND. For example, in Fahrenheit at standard 1 atmosphere pressure at sea level, if something is below 32 degrees, it's freezing, and if it's above 212 degrees, it's boiling. So we're going to use some AND logic to see whether it's liquid. It's not boiling and it's not freezing. So if temperature greater than or equal to 30, If temperature greater than equal to 32 and temperature less than equal to 212, colon, print, it's liquid. I guess we're assuming we're talking about water. Steel boils at a completely different temperature. And then you use OR to check to see if something is out of range. To check outside of a range, use OR. We're going to see if it's not liquid because it's boiling or it's freezing. So if temperature is less than 32 or the temperature is greater than 212, then it's not a liquid. So if you're checking to see whether something's within a range, you want to see whether something's between a range of 16 and 20, you'd use an AND. If you want to see if it's outside of the range, if it's 15 or less, or 21 or greater, then you would use OR. So, like I've been saying, the OR decision is when one or the other of two conditions is true. Are you free for dinner Friday or Saturday? Now that wouldn't be directly translatable to computer code, but if it was written like this is, if free day equals Friday, or free day equals Saturday, then print going to dinner, something like that. So again, for efficiency's sake, if you're doing an OR, you want to put the statement, the clause that is most likely to be true first. Whereas if you're doing AND, you want to put the one that's least likely to be true first, just to eliminate as many useless tests as possible. All right, there was a phrase up here that I didn't spot inside being defined in the PowerPoint. Okay, non-trivial. It said make the test non-trivial. The expression should be non-trivial. A non-trivial expression is one that's either always true or always false. So for example, if I had this, if age is greater than 100, and then inside there I had another one, if age is greater than 30, well that age is always going to be greater than 30 because it was greater than 100. So that makes this one a trivial expression. This is dumb and trivial because if the age was greater than 100, of course age is greater than 30. So you do have to make sure your Boolean expressions are complete. That's a restating of what I just said before. I can't do this. If x is equal to 10 or 20. I love that. I love the way it's written, but it won't work. Why? Because both things on either side of the OR have to be valid expressions. And if we block this one off with parentheses, that looks good. Yeah. But does that look good? If I wrote if 20 all by itself, no. That's completely bad syntax. So again, that's wrong. Instead, we have to do if x equals 10 or x equals 20. That makes it right. And then not reverses the meaning of it. If you're less than 18, you can't vote, right? So this could have been worded like this. If age is less than 18, output can't vote, cannot vote, right? However, we could reword it so that we could tell them that they can vote by adding not up there. So if not age less than 18, then output can register to vote. Now, like I said, nots kind of hurt the brain. If I had a choice between saying if not age less than 18 or saying if age greater than 17, I'd go with the if age greater than 17. Just instantly easier to grasp. So, but if this thing evaluates to true, the whole thing's false. If our age was 30, well, is 30 less than 18? pregnant pause. Somebody tell me. Did I hear a no? If age is 30, then it's not less than 18. So this is false. And then that not flips it to being true, and so it would print can register to vote. So be careful not to create trivial expressions. If not employee equals 1 or not employee dead equals 2, or department, excuse me. See, these should be double equals. I'm sorry that the book doesn't show double equals. Anyways, there we go. I don't get what's wrong with the top one. The bottom one is a little bit more efficient. But it's kind of like if you have this, I don't know if you remember back in math class, but you may have had something like this where you said x, or 3 times x plus 3 times y, and you could simplify it by saying 3 times x plus y. Right? Those meant the same thing. Well, to me, that's kind of what this slide looks like they're showing. Taking that and writing it to that. I guess they got rid of one of the knots, which made it easier to understand, since I've been saying try to avoid knots if possible. How did they do that? Well, they just moved the knot to outside of the parentheses, just like I moved the 3 to outside of the parentheses to get that to work. Distributive property, or something like that. So making selections within a range. If you're doing a range check, if it's going to be between the values, you use and you put the lowest and the highest value in each range. You have to figure out whether the endpoints are included or not, right? Voting age is 18. So I better be careful that I do my logic correctly. Because if I do if age less than 17 when I meant 18, or when I meant less than or equal to 18, you just have to make sure that it's going to fall exactly where you want. And I never remember whether I ought to be, when comparing against 32 degrees, whether I should make it less than or equal to. Is exactly 32 degrees considered freezing? I don't know. So I kind of fluff it. But anyways, you just have to make sure that you know whether you're going to be inclusive or exclusive. The liquid phase of water is 32 to 212 inclusive. And so since it's inclusive, I'd be using the equal signs. Also, you want to avoid dead or unreachable paths. Don't check for values that can never occur. Never ask a question if there's only one possible answer. And avoid testing the same range limit multiple times. These are all kind of abstract, and we probably need to get back into writing code before people fall asleep. So understanding precedence. Good old precedence. Multiplication happens before division, right? Now I said that if you have and or if you have or, one of them is logical multiplication and one of them is logical addition. Well, which of those was logical multiplication? Pop quiz. Is and akin to logical multiplication, or is or akin to logical multiplication? And is akin to logical multiplication. So since multiplication happens first in precedence, and happens first in precedence. So since and is logical multiplication, and or is logical addition, then by rules of precedence, and has higher precedence than or. Alright, so fire up Notepad or Word or some kind of document editing thing. And we're just going to set up a series of values. X is going to equal 10, and Y is going to equal 20. X greater than Y, X less than Y, X equals 10, and X greater than Y, X equals 10, and X less than Y, X equals 10, or Y equals 10. Why did I say 10 and type 20? X is equal to 10, or Y is equal to 10. X equals 20, or Y equals 20. X equals 10, and Y equals 10. X greater than 10, and Y less than 20. X greater than or equal to 10, and Y less than or equal to 20. Alright, sorry for all that. I could, I guess, just upload this, but I want you to hit tab and then put either the word true or false. And I'm going to do a couple of them in the middle. I'm going to give y'all a second to finish catching up. Now, for those of y'all who have caught up, I'm going to go ahead and do like that one and that one. So, is X equal to 20? No, it's not. But this is an OR, so either side could be true. Is Y equal to 20? Yeah, so that's definitely a true. How about the next one? Is X equal to 10? Yep, but it's an and, so both sides have to be true. Is Y equal to 10? Nope, so that made that a false. Okay, so X greater than Y, is that true or false? Is 10 greater than 20? False. How about the opposite? Is X less than? True. Now, I forgot to use less than or equal to or greater than or equal to, but you know, well, I guess I did that way down here at the bottom only once. How about X equals 10 and Y greater than 10? Well, and means both has to be true. So, X is 10. X is greater than Y? No. So that's a big fat false. Whoops. Didn't mean to capitalize it. This one's looking false. X equals 10 and X less than 10. It can't be both equal to 10 and less than 10, so that one's definitely false. That one looks like a mistake in my typing. How about X equals 10 or Y equals 10? Or means only one side or the other has to be true. So are either one of these sides true? Yep, so the result is true. X equals 20 or Y equals 20? Well, one of them is 20. And or means that only one of them had to be true, so that's true. X equals 10 or Y equals 10? Excuse me, X equals 10 and Y equals 10? Well, and meant both of them have to be true. And one of those definitely is not, so it's false. How about the next one? Is that true or false? Definitely a false, because 10 greater than 10? No. 20 less than 20? No. If I'd made them less than or equal to, like I was trying to do down here, then we might have a shot at it. Alright, and lastly, X greater than equal to 20 and Y less than or equal to 20. Well, that's definitely false. And while that one was true, and meant that the whole thing came out being false. Now I did an assignment that I made one time that had like 40 or 50 of these, and people hated it, and I hated grading it, so I don't make people do that anymore, but I hope you have the idea by now. Lastly, we're going to do like 3 more, and I'm going to type them in slowly. So, not x equal 9, and not y equal 10. And then I'm going to use parentheses. Not parentheses x equals 10 and y equals 20 in parentheses. So these we just have to kind of pick out individually, the pieces. Well, is x equal to 9? X is 10, so x is not equal to 9, so that's definitely not true right there, but it's got a not in front of it, which changed that false to a true. And then is y equal to 10? No, but the not turns it to a true, and so the whole expression is true. How about the next one? Is x equal to 10? Yeah. Is y equal to 20? Yep. And not of all of this true is false. You got it. And since I only have 2 variables, I don't really see much of a point of trying to mix the expressions with and ors. Maybe just 2 of them. A equals 1, B equals 2, C equals 3. Oh, I should think about this one before actually. Forget it. Forget it. Not working in my brain. I'm not going to ask it on an exam first. I was trying to come up with things like when we had A plus B times C, and we needed to know which one had to be done first. Which have I said had to be done first? Ands or ors? Which one is akin to logical multiplication? And so you have to do your ands first. So if you had something like this, x equal y, or x less than y, and x greater than 3. We would have to zero in on this one first, and we could figure out whether that was true. And I believe it is. So that would evaluate the true, and then we could flip over here and check to see if that was true or false. But we've already found one that's true, and since the rest of it's or, then we're already good to go, and the whole thing would evaluate the true. So seeing that and means that we would cluster those inside the parentheses in our brain as we were looking at it. That's how the computer solves it. Okay, so here's our homework assignment based on ifs and elses. And it's got a couple of ors and a couple of ands in it. Guess I'm just going to copy this into a notepad file because it's kind of hard to read. Oh, you didn't. Okay. Go back. Alright, so our homework assignment. We're going to ask the user for their age and ask them for their years of employment. Remember that you then have to convert them to floats before you can do anything else. So, the very top of it's going to look something like this. Right? Age equals input, quote, what is your age, end quote, in parentheses, and then it's going to show age equals float, parentheses, age. And we're going to do the same thing for the years of employment. Years equals, you know, input, how long have you been employed, or years of employment. Question mark, end quote, and then years equals float years. I'm hoping that by now y'all remember how to do that kind of input, but just making sure. So we're going to ask them for their age. We're going to ask them for their employment. Now, if the age is greater than 17, and if the years of employment is greater than 2, we're going to print you get free checking. If the age is less than 17 or their years of employment equals 0, we're going to print enroll in the training program. Poor 2-year-olds. They have to go into the training program. Ask the user how many calls they have made and how many minutes they have talked. Again, you're going to have to do that float business, input and float. If calls are greater than 100 or minutes greater than 1,000, we're going to tell them upgrade to the higher plan. If the calls are less than or equal to 100 and the minutes are less than or equal to 1,000, we're going to print stick with the current plan. If our calls equal 0, we're going to print you may as well cancel your plan. Tell you what, I'm going to modify that to say and minutes. Can we stretch this out, please? Well, if the number of calls is equal to 0, then obviously the minutes they've talked is 0. So that would be a trivial clause to add to it. If we said if calls equals 0, there's no reason to check to see if minutes is equal to 0 because there's no way that minutes could be anything other than 0 if they haven't made any calls. I guess receiving calls. But those don't count against you, do they? I don't remember. Who keeps track of minutes anymore? Okay, so that's the homework. I should have tacked on something else, though. So I am going to tack on one more piece to the homework. And based on the age, print whether they, that's almost a separate assignment. I'm going to leave that one off. We'll get to that one on Monday. Never mind. I'm not modifying the assignment. All right, guys, that's the homework based on this. It doesn't do everything we did because it didn't talk about priming loops, right, where we were asking for data and summing it and stuff like that. But that's okay. The ifs and the ors and the ands, those are the important things. Well, I won't say those are the important things, but those are incredibly important things that I want us to focus on. Now, normally I would make this due Tuesday night of next week, but Wednesday is break. I really strongly recommend that you get this done before the break rather than after, right? Sunday night, just like the last homework would have been. But I am going to make it do, whatever, right? The week after the break. But don't wait that long because you may have questions over it. And if you have questions over it, then we can talk about it on Monday. So don't blow it off for a week and a half if you can work on it this weekend. Just because it's pretty important stuff. Try to get it done early. Y'all feel like getting out? Everybody raise your hand if we're going to be done. Madison's saying, no. You're wasting my money if you don't teach me the extra 10 minutes. Okay, let's go and make our Dropboxes and stuff.